S7 network. Thus, telcos needed a new framework to handle voice, VoLTE, support SMS over IP, SMS over IMS, provide roaming, deliver emergency calling. IMS became mandatory for voice in LTE. IMS equals VoLTE plus VoW Wi-Fi plus RCS plus multimedia calling. The push from 4G rightward arrow 5G dropped all legacy circuit switching. IMS became the universal voice/multimedia anchor for 5G. Voice over NR, VoNR, requires IMS. IMS integrates with 5G core, 5GC. RCS messaging uses IMS. Video calling uses IMS. IMS is now the global standard for heavy checkmark VoLTE, heavy checkmark VoNR, heavy checkmark VoW Wi-Fi, heavy checkmark rich communication services, RCS, heavy checkmark carrier grade multimedia. Summary: how IMS emerged. The emergence of the IP multimedia subsystem, IMS, was driven by the need to unify traditional voice telephony with modern packet switched data services. It represents a shift from fixed, physical connections to a flexible, software-driven architecture. The evolution of the voice network. Before IMS, telecommunications were split into two distinct islands: circuit switched, CS, domain, used primarily for traditional voice calls, relying on dedicated physical paths and hardware like the MSC server and HLR. Packet switched, PS, domain, used for data and the internet, where information is broken into small packets to be sent across a network. Key drivers for IMS emergence: convergence of services. As mobile technology evolved from 2G/3G, which had separate CS and PS domains, to 4G LTE and 5G, carriers needed a way to deliver high-quality voice over the data-only LTE framework. Protocol standardization. IMS adopted SIP, Session Initiation Protocol, as its language. This allowed telecom networks to talk to internet-based applications, enabling features like video calling and instant messaging alongside standard voice. Infrastructure efficiency. Moving to an all-IP core network allowed operators to retire expensive, legacy circuit-switched hardware and replace it with more efficient, scalable server-based architectures. Quality of service. QoS. Unlike early over-the-top, OTT, VoIP apps, like Skype, IMS introduced the PCRF to ensure that voice packets always receive priority over general web browsing, preventing dropped calls or lag. IMS as the bridge. IMS emerged as the specialized brain in the core network that allows a user on a high-speed LTE or 5G connection to still reach someone on a traditional PSTN landline. By using gateways like the MGCF and MGW, it translates modern IP signals into the beeps and boops of the old-school phone system, ensuring universal connectivity. IMS emerged because telecom operators needed a way to deliver voice plus video plus messaging over IP, carrier-grade reliability and QoS on IP networks, global roaming and interworking for IP-based communications, a standardized SIP-based architecture for multimedia services, a replacement for legacy circuit-switched voice networks, a foundation for LTE and 5G, which have no CS domain. In simple terms, IMS emerged as the global, standardized, IP-based control layer that merges voice, video, data, and messaging under one architecture across 3G, 4G, and 5G. Here's a clear, structured IMS, IP multimedia subsystem, architecture diagram showing all major components, interfaces, and their roles. IMS architecture diagram plus application server, as, service layer plus ISC, SIP, V plus SCSCF, serving, session control function plus CX/DX, SIP plus diameter, plus HSS, subscriber, home subscriber server plus caret, plus ICSCF, interconnect, incoming/outgoing domain plus caret, SIP plus PCSCF, proxy, first contact point for UE plus caret GM, SIP, plus UE IMS plus. Explanation of key IMS components. Component role: UE, user equipment, SIP-capable device, mobile phone, tablet, VoIP device. PCSCF, proxy CSCF, first contact point in IMS, forward SIP requests, enforces policy. ICSCF, interrogating gateway for incoming/outgoing SIP from other networks, hide CSCF, network topology. Core session control, handles registration, call/session routing, and SCSCF, serving CSCF, service invocation. HSS, home subscriber central subscriber database, stores user profile, services, authentication server, data. Hosts value-added services, VoIP, messaging, video call, conferencing, as, application server, RCS. Interfaces in IMS interface connects protocol / purpose GMUE left right arrow PCSCF SIP / UDP or SIP / TCPCX / DXSCSCF left right arrow HSS diameter, authentication, authorization, profile ISCSCSCF left right arrow as SIP, service control and invocation MWCSCF left right arrow CSCF, other IMS, SIP signaling for interdomain calls SH application server left right arrow HSS user profile info for services. Optional add-ons PCRF, policy and charging rules function, QoS and charging rules BGCF, breakout gateway control function, routes calls to PSTN / legacy networks MGCF / MGW, media gateway, interworking with TDM voice network summary 1. UE registers with IMS via PCSCF rightward arrow SCSCF rightward arrow HSS 2. Calls / data sessions are controlled by SCSCF, optionally invoking as for value-added services 3. IMS is fully SIP-based and can interconnect with other IMS networks or legacy networks via ICSCF / BGCF / MGCF 4. IMS provides carrier-grade IP multimedia services with QoS, mobility, and billing support. Here's a clear and structured IMS call flow diagram for a typical VoLTE / IMS voice call. It illustrates how the UE registers with IMS and sets up a voice call using SIP signaling. IMS call flow diagram, registration plus voice call, UE PCSCF ICSCF SCSCF HSS as dash, register, dash dash, register dash dash, third REQ, dash dash, user auth dash 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 auth RESP, dash dash 200 OK dash 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 200 OK dash 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 200 OK dash dash, invite dash dash, invite dash dash, invite dash dash, service REQ dash 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 service RESP dash dash. 180 ringing dash dash 180 ringing dash dash, 200 OK dash 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 200 OK dash 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 200 OK dash dash, act dash dash, act dash. Equals RTP media voice media dash by dash dash by dash dash by dash dash 200 OK dash 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 200 OK dash 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 200 OK dash explanation of call flow 1. Registration phase 1. UE rightward arrow PCSCF, UE send SIP register to register with IMS. 2 PCSCF rightward arrow ICSCF rightward arrow SCSCF, registration is forwarded to serving CSCF. 3 SCSCF rightward arrow HSS, authentication of the user via IMS aka. 4 200 OK, user successfully registered, ready to make calls. 2 call setup phase 1. UE rightward arrow PCSCF rightward arrow ICSCF rightward arrow SCSCF rightward arrow as, SIP invite sent to initiate the call. 2 application server, as, may provide services like call forwarding, voicemail, conferencing. 3 180 ringing, called party's UE is ringing. 4 200 OK, called party answers, SIP signaling completes call setup. 5 AC, confirms the call session. 6 RTP media path, actual voice flows directly via media path, can traverse PCSCF or MGW depending on topology. 3 call termination phase 1. By, initiated by either UE. 2 200 OK, call teardown acknowledgement. Keynote SIP is the main signaling protocol in IMS. RTP, real-time protocol, carries voice media separately from SIP signaling. PCSCF, ICSCF, SCSCF handle call control, routing, and service invocation. HSS provides authentication and subscriber profile. As provides value-added services. Optional enhancements PCRF integration for QoS and policy control MGW, media gateway, if interworking with PSTN is needed VOW Wi-Fi /VONR call flow variations for Wi-Fi or 5G NR.